Okay. So let's close some stuff and then open some stuff. Maybe check Twitter real quick for once. Looks like Neonomycin's dying for whatever reason. Okay. And I think, I don't know how caught up I am with downloads for my stream, but okay. I think I don't have to bother with it today. So let's get back to work. Cool. I'll leave it like that then. Okay. So let's get back to work. Oh, wow, that's a lot of lag. Why am I lagging? Guess we should start by closing some tabs. How's that? Okay, no new info there. We can close that. There. Now will it load? Maybe I should just reload the entire page. This is gonna load. Seriously, is it not gonna load? Do I have to download this? Let's try it in a new instance. At some point we might just move away from Google Chrome, but anyway. Okay, yeah, maybe I should download this. Or is this just gonna be the transcript? That's just gonna be the transcript, isn't it? Shit. Are the recordings under files? These PDFs, but well, actually, no, the PDF will have it on there, so I can download the PDF while I wait for the video to buffer. There we go. Okay. Yep. Oh wait, no, this was from, but this isn't from office hours. Or no, it is. Yeah. Okay, here it is. Here's the tips. Is this thing really not going to load? Whatever. Okay, so he says step 1, find the Coriolis acceleration in terms of x dot, y dot, c dot. Okay, we sort of did that. And then find the position and velocity of a small element d alpha on the ring as a function of t, phi, and phi prime. Okay, so then find, so we did that sort of. So we have position and velocity. We used velocity and the omega vector to get well, I guess that's the, you can relate that to the Coriolis force, and then you can relate that to the acceleration. And then the tangential component would then be a sine alpha from, or applied to the Coriolis acceleration then, just to get the tangential component of the acceleration only. So they say find Coriolis torque by integrating, what was it? Where are we supposed to integrate? Oh, opponent trash. Oh, I see, he left. Okay, yeah. Well, yeah, again, thanks for coming by. I don't know if you're going to check the VODs, but yeah, thanks for popping by. Yeah, LSAO, yeah, he's school, yeah, so, yeah. Anyway, okay, so... integrating what? Oh, here, okay, so they said they're taking the tangential component times, okay, so... Here's the integral. Sorry. So there's some phi dependence that we end up with that's kind of in the way. We can adapt to page 353. Okay, let's try looking at 353 again. Oh, this stuff. Okay, yeah. So not quite what I was looking for, but sure. Excuse me. Name it. So we've got the tangential component. I feel like we have an extra phi dependence in here. They iterate with respect to phi, but I guess my phi is their alpha. Is that right? That doesn't sound right. Then I should be on the sine squared alpha here. Which I guess I do. Okay, yeah. Let's double check to make sure we've got everything. Okay. Alright, there we go. Alright, so the R dots have a phi dot component that I forgot to write in. It's okay, because we'll just write it in now. There we go. Okay, so we end up with this. Phi dot? Is phi the... Yeah, phi's the right one. It's alpha dot here, but that's because they use a different variable. Yeah. Alright, so we should end up with sine squared alpha phi dot, and then that square term that I guess can technically simplify into something. So we found the tangential component, then we want the Coriolis, the torque from the Coriolis force. We find that integral. Okay, so we want to rotate 0 to 2 pi, or alpha from 0 to 2 pi, so then we'll dump in this entire big integral that we have, or I guess we can simplify it a little bit. We eventually want to just have alpha by itself, so I guess negative 2 r omega phi dot sine squared alpha, and then sine theta cosine, or sine phi cosine theta. I feel like that's an identity. Okay, sine alpha cosine beta minus cosine alpha sine beta. This is sine alpha minus beta. Okay. So in this case, sine phi minus theta is what it would be. Yeah, okay. So that's a little bit of simplification that we can do. So now we'll put that in. We'll put negative 2 r omega phi dot sine, I guess sine theta minus, or phi minus theta sine squared alpha times 2 r, or mr rather, mr over 2 pi d alpha. Take out all the constants, so that's going to be negative mr squared omega phi dot sine phi minus theta over pi from 0 to 2 pi sine squared alpha d alpha. Sine squared alpha d alpha, isn't that from 0 to 2 pi? Isn't that just yes, it's just pi. Okay, so those pi's cancel. You end up with the torque due to Coriolis is going to be then negative m r squared omega phi dot sine phi minus theta. Okay. So then the, what is it? the angular velocity is gonna be what? What are we trying to find? We're at number 9.31. What are we trying to solve for? If this is chapter 12, totally wrong section. No, we're not gonna find anything relevant. Oh. Oekaki ni modoritai yo. と言いながら、髪の毛の色付けちょっとなんで困ってたからまあいいか。So we want to find that the speed of the water should be 2 omega r cosine theta. How do we end up with the cosine theta? Whatever. Let's keep going. Okay, so dot r, liquid r. Well, okay, so whatever. So they're saying that then is gonna be t phi equals 0 to t phi equals pi of the Coriolis torque over mr squared, which also happens to be okay. So we have 1 over mr squared times integral from phi equals 0, or the time for which phi equals 0, time which phi equals pi of torque, which is going to be negative mr squared omega phi dot sine phi minus theta dt. I think we can convert this because we got the phi dot there. These two will cancel. We end up with some t integral from theta equals 0 to some t integral for theta equals pi of negative omega phi dot, which we're going to use in a moment, sine phi minus theta dt. We're going to say phi dot is going to be d phi dt. So d phi dt is just d phi dt is just going to be d phi. So we end up with an integral of phi from 0 to phi equals pi of negative omega, which I guess can come out now actually. Negative omega sine phi minus theta d phi. Okay. So if we do that, then this is just going to be a cosine, right? Cosine integral. So it's going to be cosine phi minus theta, or negative cosine phi minus theta, divided by... Aren't I missing an r? I guess not. But phi minus theta. Am I supposed to... I think the integral right here. I feel like I'm missing a term. Or I feel like I have too much of a term. Yeah, actually, no, yeah. So there shouldn't be a constant that gets generated because there's nothing being multiplied by phi. So we have negative omega times negative cosine phi minus theta valued from 0 to pi. So we're going to get negative cosine pi minus theta plus cosine 0 minus theta. This will just be cosine theta this will be just cosine of pi, which is just going to be, is this -1? What am I missing? Oh wait, I got rid of the theta for some reason. That's not supposed to happen, yeah. Negative cosine pi minus theta. Right, so I still need to determine how this relates to theta, right? Okay. So I should be able to do this. I should be able to do negative cosine theta minus pi plus cosine theta, and times a -1 on the outside, which then that doesn't do shit. Definitely negative cosine, because that's literally the last step I need. I know that's going to be the case, or I'm pretty confident that's going to be the case. So what do I do about this one? Because if I get a sine, it gets in the way. Show that the speed of the water just after 180-degree turn should just be 2 omega r cosine theta. So this first term I really do think should just be 0. Is there another identity I'm forgetting? Cosine 2a? No. Cosine a plus minus b is cosine a cosine b plus minus sine a sine b. That doesn't look like that'll help. Cosine at pi is going to be... Well, let's type it in. Is that just negative x? Oh, okay, so this is the identity I need. This is equal to then negative cosine of theta. So then you get positive cosine theta plus cosine theta. So then the angular velocity of the liquid is going to be negative 2. Negative. Well, am I missing a negative term that do I have an extra negative? No, but that works. Yeah. Oh well, I'm off by a factor of a negative. That's I think that's acceptable. Cosine theta. Okay. So then he said that the velocity of a liquid, V liquid, is going to be omega liquid times r, which gives us -2 r omega cosine theta. Okay. You know what? I don't know where the hell. Yeah. I don't know where it was supposed to turn into a positive, but whatever. It is supposed to be that. All right. Anyway, cool. Okay. Cool. So that's almost that. So then we also want to say for r approximately 1 meter and theta is approximately 40 degrees, the liquid is then going to be 2 times 1 omega cosine 40 degrees. Is cosine 40 degrees some clean number, or is it just some... I guess it's just going to be 2/9 pi. Unless we needed to sub in omega as well. I don't know what the omega of the Earth is. I'll just look it up. So let's see. Pi radians, and then this equation is represented as 2 pi radians over 1 day, which works out to moderate angular velocity of approximately 7.2921159 to 10 to the negative 5th radians per second. Yeah, I don't want to bother with that. Cool. So that's that question. We'll join that with the rest of my assignment, I guess, or we'll do it right now as long as we're here. Okay, and this should be the last piece. Well, 遅いのもまあわかるでしょう. Okay, so 6, Taylor 9.31, you got these parts, and you find R, you do R cross omega, you get this thingy. You do that, you get the Coriolis force, you get the Coriolis acceleration, you get the torque, and then you get the angular velocity of the liquid by integrating with time, and then you get the velocity of the liquid by hitting that with the radius of the tube, and you should get that. Yeah, okay, cool. Cool. So let's, so that was number 6. Let's jump back to number 3. Yeah, anyway. Shut up. Cool snack. Keep forgetting to, but yeah. Okay. The problem number 3 with the is Taylor problem 7 point or 10 point. Yeah, let me actually label these freaking problems. Okay. So problem 1, that was supposed to be. This is Taylor example. So you do the 4th. Okay. Someone's having fun outside again. Again, not that that's a problem, it's just more of an observation. Okay, so Taylor problem, or yeah, problem. Okay, so Taylor 10.2 with sphere. Okay. Problem 3 is going to be Taylor 10.5, but with the following change, the density K1 plus K2z, where K1 and K2 are positive constants. Okay, we had thought about this a little bit, right? So let's go to our handy dandy second browser for accessing Slater questions or solutions. 10.5. I want to go to this. So I think 10.5 is with the uniform mass density. So pretty sure in this case we have to swap in for a function of z. That should change the integral as well. Let's double check if that's what we're supposed to do. Yeah, so here now we're having rho defined to not as m over v, but k1 plus k2 z. Yeah, okay. So, check that. If you set k2 to 0, you get the result in 764, which I assume is just with k2 to 0 means you should end up with some constant k1 as the mass density, which means that assuming k1 equals m over v, you should end up with the same result in the question. Okay. Okay. So 10.5 says a uniform solid hemisphere of radius r has its flat base in the xy plane. I forgot to mention that this radius is r, isn't it? Okay. With its center at the origin, use the result of problem 10.4 to find its center of mass. Comment this and the next two problems are intended to reactivate your skills at finding centers of mass by integration. In all cases, you will need to use the integral form of the form of the definition 10.1 of the center of mass. If the mass is distributed through a volume as here, the integral will be a volume with the integral dm equals rho dv. Okay, so let's go back. So we're supposed to use 10.4. We're also supposed to use 10.1. Okay, so from question 10.4, from is that equation 10.1? Okay. dm equals rho dv. Okay. So using definition 10.1, result of problem 10.4 on the volume half a ball we find. Okay. The density. Well, what are we getting from 10.1? I guess we're getting R, so. Okay. So from 10.1 we can get 1 over m integral r dm. Of course, in this case, dm is going to be rho dv. So, okay. So let's put the sign information up here. Let's see. So if we start with that capital R, the position vector for the center of mass is going to be 1 over m integral r dm. In our case, we know that that's going to be, let's see, 1 over m. So I guess capital M. So R is going to be, yeah. Or wait, no, we want dm. dm is going to be rho dv. So we have r rho dv. Subbing in what we get. Let's see. R. It's going to be k1 plus k2z. From the change that we want to put in. And dv will then be I guess for spherical coordinates And then we just change the integration bounds for which we are doing this integral for. Okay. So 1 over m, what is m? I have no idea what the mass is here. Well, actually, wait, so the density is this, density is... mass over volume. So... wait, if we know the density, then... but I don't know how to decouple the mass from that. I guess is the problem. Yeah, so we're gonna have to leave it 1 over m, and just know that k1 plus k2z contains the mass over volume kind of quantity. Okay. Alright, so that's fine. So then I get 1 over m integral r k1 plus k2z multiplied by the triple integral stuff for volume. So that's going to be sine r, I guess r squared sine theta dr d theta d phi. What did I say dv here squared is r squared sine theta? Where do you get this cosine? From the integral in equation 2, only contribution will be along the z-axis due to symmetry. It's for coordinates we can parameterize z as r cosine theta. Let's see, so our system has... it's a hemisphere with the density being some constant k1 at the plane, and then increases to some quantity k1 plus k2 times z as you rise up. So the axis of symmetry would still be the z-axis, I think. Yeah, should be able to rotate about the z without any change. Yeah. Okay, so then that parameterization should work. So then, yeah, we are using the definition that the volume in spherical coordinates is r squared sine theta dr d phi d theta d phi, whichever you want. And they get this cosine because... where do you get... or where do you get... oh, Brass, welcome back. Comfort stream. I don't... comfort streamer? Okay, I guess. Yeah, anyway, as you can tell, well, actually, I don't have the screen connected just because I'm low on battery, but, for my iPad, but, as you can tell, more physics, yay, woo. Anyway, yeah. Alright, so... yeah, so you should end up with 2 integrals. You should get one integral that looks identical to the original situation, which is going to be, let's see, we're going to have an r cubed, dr, actually, I should do it like this then. Should end up with 1 over m integral r k1 r squared sine theta dr d phi d theta, and we should also end up with a 1 over m integral r k2z r squared sine theta dr d phi d theta. There. Oof, physics. Yeah. Oof, indeed, especially since, I don't know, it's been especially tough to kind of focus this semester for whatever reason, so it's been extra tough. But you know, we're just hanging in there. You know, just gotta hang in there. Yeah. How's life? Well, life is physics is life, I guess, at this point. Jokes aside, yeah. I've been working on that character model update that I've mentioned for ages now, and I'm kind of reaching the point where it's actually kind of coming together. It's obviously not perfect, but it's I think it's the as good as the model's gonna get, you know, at least for the time being. I'll have to put in some substantial effort into actually practicing drawing before it's gonna get any better. But so whether or not that the model's rigging is going to be done by the stream anniversary is kind of up in the air, but it's at least it's like, you know, I was planning it, I was aiming it for the anniversary of the stream, so I'm kind of glad it's at least somewhat progressed. I can, even if I can't have it rigged, I can still say I at least drew it, right? So let's say 2 pi, and then it's a hemisphere, so theta goes from 0 to pi over 2. Okay. Yeah. But yeah, so besides that, I don't really, you know, what has gone on so far? I don't know. Let's see, r cubed, sine theta, and we're gonna, I guess z hat is r cosine theta still, I think. Or, z hat is r cosine theta, which the cosine component of, let's see, cosine of theta comes out. Cosine is going to be the vertical component of, yes, it is cosine theta, so it is r cosine theta. Sneak peek. Actually, if you go to the, I'll try to hook it up right now, but even if I can't, then you can still look it up. You just have to look at the previous VODs for like the past, well, not yesterday. I didn't have time to work on it yesterday, but I've been basically working on it after stream or during stream for the past, I don't know, most of the past couple days. So let's see if I can get the screen mirroring working. Yeah, I've actually struggled a lot with it in terms of color scheme, because I obviously take a lot of inspiration from Natsui to Matsuri, right? So I've noticed that I've been subconscious. There's some intentional references to her, but there's also like a shit ton of like accidental, like, you know, kind of similarities that I didn't plan for. So kind of, you know, looking at the model, being like, okay, let's do this much today, going to sleep, and then waking up and being like, wait, this is just totally copying her, has kind of derailed the okay, why is it disconnecting? Let me reboot the screen recorder. Yeah. Oh wait, that's not what I want to do. There. Oh, that's not. Oh, I think that's about right. Okay, so if I became a little smaller, then you'll have to let that go, because I hit the wrong window. I was resizing the wrong window. Okay, so let's see if this works now. Yeah, so hopefully this works. Okay, yeah, see, okay, so first let's get, okay, so those are all enabled. Okay, so I can close this window without causing trouble. Studio Paint. Oh, lab code. Yeah, so I'll talk about that in a sec here, actually. But let's see. I don't want. Okay, you know what? I'm gonna have to go straight to my iPad screen, and in fact, I'm gonna close these windows too, just so there's no accidental info leaking. There we go. All right. Or actually, wait. Let me blur it first, and then sorry, I have to open my file system, and I don't know if there's anything problematic in the file system. But yeah, so I gave up on a couple things. The one thing I gave up on, not in terms of setting, the setting's gonna stay fine, but what I gave up on was drawing clothing. I was like, I'm spending so much time on just drawing the, you know, the face. I'm like, I don't have time to do clothing. So I've kind of just accepted that, you know, here, it's just gonna be upper body, and I totally got, you know, or maybe not lazy. This isn't, I guess, intentional laziness. I was like, you know, I'm not going to be able to have time to draw more than this well. And even then, you know, there's like, what is the shading on the bottom of the ponytail here, right? Or the hair down here? Like, what is this shit? I don't know. What is this shading? It's not good down here, I'm going to be honest. I've wanted more time to think about it, but, you know, I've already spent so much extra time on this. I think the upper head, though, if you just look at the top of the head, I feel like the shading's a little bit better than just not having it. So Yeah, I of course, the original design did have a lab coat and stuff, but I was like, I don't have time to to model all the thing for the lab coat. So I just said F it. It's just gonna be like upper body, not even have like clothing on. It's just gonna be like half made. Like it's literally just gonna be like this. So, but see, this will make it easy because I don't need to shade any part of the upper body then, and I can just leave it, and no one's gonna care if I have hands or not anyway. So I'm moving everything telekinetically or something. We can make up some excuse. But yeah, so yeah, like I made the hair gray because I was originally green mark near the left eye. Oh yeah, sorry. So it's not totally done yet. There's gonna be like green highlights, so that's just a little bit of the highlighted hair there. Um, Yeah, so I was planning to mix in some highlights there, some highlights in there, here, all over the place, just lightly. A white dress, yeah, you can just say it's a white dress, use your imagination. In fact, yeah, so my excuse will just be that, you're supposed to use your imagination. When you make like, you're not, you're supposed to fill in the blank with your mind, some BS like that. But I'm gonna be honest, like, do people really look at the Easter egg? Easter egg? For what? I don't know. Oh, the eyes. The eyes, I guess, do kind of look like an Easter egg, don't they? A little. But anyway, yeah. So yeah. So this is what I've planned. I'm gonna basically this is ready, not ready to go, but basically I'm gonna use this and to finalize the design. But again, that's gonna be after I finish my assignments. so so unfortunately, we have to go back to here. Um, Wait for the blur to kick in and the screen resizing. Yeah. So yeah, so that's that little preview. Again, if you want to look at it a little bit more or see kind of the work in progress stages, feel free to go back and look at the VODs. I'm trying to download all my VODs to upload them to YouTube, but I might miss a couple. So if you are curious, you might want to take a look, before it's too late. If you don't care, then green highlights. Yeah, exactly. I wanted to retain some of the green, but I also realized green hair is such a pain to chroma key. you know, like I'm gonna be honest, green hair is such a pain to chroma key. I was like, if I use green, well, here's the real issue, and I'll talk about this just because I'm kind of on a mental break. In fact, let me get a drink. We're taking a short break, but yeah, so I wanted to retain some green. I didn't want to just totally change everything, but the green hair was also totally just a placeholder. And again, as I mentioned earlier, I didn't realize how much of a pain it was to chroma key when your hair is green. um, so, but yeah, so basically, if I made the hair green in the drawing too, then ultimately what'll happen is that, just in the shading process, you'll have to use multiple shades of green, right? And really that's the issue with chroma keying. If you use any of the chroma key colors like red, green, or rarely anyone uses red because for the same reason. But basically you have to, well, maybe if you've already done it before, this is going to be a little bit redundant to explain. But when you chroma key, you have to choose what color you're targeting as like the transparent color, and then you also have to tell the program, if you're doing it digitally, how close you want colors near that color to, or you want to basically say what color and then how much around that color you want to classify as transparent. So as you can imagine, if you have your hair color green, then you have to make your chroma, you have to choose like a really specific green color as your background, and you have to make it really specific to that color, or else you'll start catching like the hair. But again, the more variety of green that's in your hair, the harder it is to choose a color that doesn't overlap with your hair color. You know what I mean? So it just became such a pain. Now, my workaround for that is if it's just green highlights in the hair, then I can have like one exact shade of green as the highlight. And I can just choose that color to not conflict with the chroma key. And then ta-da, no more issues with chroma keying and transparency. So that's the plan. Of course, that plan doesn't kick in until I'm done with my assignments this week, and I still have like 3 problems left. And the bright side is I got 3 done, so yeah. So anyway, I'm gonna take a quick drink and then get back to work. But yeah, I didn't want to just like totally change design because, you know, eye color is changing, outfit as well disappearing. I was like, you know, there should be something that's retained between designs, right? So I was like, well, we'll try to retain the green highlights this time around. Yeah. Oh wow, something's laggy. Oh right, right. This is also another interesting thing. I finally figured out what the limits of my iPad is. It's basically it's I think it's about 30 yeah, about 30 clipping masks in Clip Studio Paint and a total of like maybe like 80 layers. That seems to be, or actually so it should be about, yeah, like 80 layer masks, maybe like 15 regular layers, and then like 30 clipping masks. It seems like after all of those kick in, then it finally starts to crash Clip Studio Paint. So for anyone that's looking for some idea. Oh, actually, it's those settings for a 4896 by or not 48 4096 by 4096 pixel canvas. That seems to be the base model iPad from so the iPad 6th gen seems to be able to do that, but after that starts, you know, well, it's already a little bit choppy, but that seems to be the max that it can support. Yeah. I mean, again, I'm impressed. Clip Studio Paint really works well, I think. It's my fault for choosing such a large layer size. Cubism, the software that you use to rig your model, to add joints and stuff, right? That only allows or you're advised to import things on a square canvas essentially, and they tell you to use powers of 2. So, you know, naturally, that's gonna, you know, for resolution's sake, you'll probably choose something like 1024, 2048, or then again, I wanted to go one higher just so that resolution wouldn't be an issue, and I ended up choosing 4096. We'll see how it works. If mine is way too fine that there's no substantial benefit, then I can always scale down the entire thing to half, and then that'll be 2048 by 2048. Of course, if things are lagging out right now, you would expect then by reducing the resolution to half in both axes, I should be able to fit maybe quadruple the number of layers. So when you imagine that, that's pretty crazy, right? Because that means that theoretically, again, just purely by speculation here, but we can speculate Clip Studio Paint to be able to support something to the tune of like 400 layers on an iPad. Like, that's pretty crazy, I think. Like, impressive. Like, that's pretty impressive that is optimized enough to be able to do that on, again, a base model iPad of all things from 2 years ago, right? 2-3 years ago. I think that's about how old it is. Yeah. So anyway, well, let's get one more drink. Although I speculate that the layer mask, or sorry, the clipping mask, might be a little bit more resource intensive than the other layers, like compared to just a default layer, because it seems like the other layers there was no issue duplicating a shit ton, but with the clipping mask it seems like that's the specific one where if I duplicated a ton, then things start to lag out. So I'll have to look at what like workflow optimizations I can use to have clip to keep Clip Studio Paint alive, I guess. All right. So anyway, we have these two integrals, r cubed sine theta, r cosine theta, dr d phi d theta. Okay, so this one we can kind of already see the outcome because we're looking at the solutions, to be honest. I don't know, we'll compute it. It's just, this is the typical, if you had a solid or a hemisphere with constant density, where would the center of mass lie? And this guy over here is going to be kind of the modifier that we get from adding our k2z hat component. So I guess we'll do them side by side. Sine theta, so that just be negative cosine theta, evaluated from 0 to pi over 2. So we get 0 plus 1, which is consistent with what we were expecting, 2 pi k1 r cubed over m as our first term. Over here, we're going to go through a little bit more of a hassle. Get r to the 4th, dr from 0 to r. We get, is it cosine theta? It should be cosine theta, yeah. Shouldn't be phi. Alright, so we're going to have a d phi here from 0 to 2 pi. We have a sine theta, cosine theta from 0 to pi over 2 because it's a hemisphere. D theta. K2 over m. It's going to look stupid, but I'm going to double check what the integral of sine theta cosine theta is. Well, if I had to guess, it's probably doing this. It's probably doing 1/2 sine 2 theta and then just doing an integral that way. That should be, I'm pretty sure, but also I have the internet in front of me. I'm not going to not check it. Like, I have the freaking internet in front of me. Why wouldn't I check a simple computation like that? So you should end up with like a cosine squared? Why didn't I buy cosine squared? I mean, I guess you can use the, there's an identity, right, to convert like cosine squared something into, is that really weird? Is that what happens? Let me do it real quick. So, first of all, sanity check. 2 sine theta or 2 sine x cosine x should be 2 sine x, right? Yeah. So if I did 1/2 integral 2 sine theta cosine theta, I should be able to rewrite the integral as integral 1/2 cosine 2 theta, or not cosine, sorry, sine theta, right? Yeah, so then you do the integral of that. That'd be a cosine then, 2 theta. It's a negative, but put that negative out here. Because yeah, if you were to integrate it, then you'd get a negative sign, so yeah. You'd also end up with a 2, right? Yeah, because if you would cosine theta, and you wanted to end up with 1/2 sine 2 theta. This is why I did bad in calculus, right? Okay, sanity check. Cosine 2 theta. Derive it, it'd be 1/2. Or sorry, no, it'd be 2. If you took the integral, then you would get, or sorry, not integral, derivative, you get negative sine 2 theta times 2. So why can my brain not do this? What did I start with? Sine 2 theta, so then that would have been 2 times 2. Sine theta, cosine theta. And that's... Why can't I do this? What am I何してんだ俺 So this is, yeah, this is just gonna be, right? Nani? What am I missing? Okay, sanity check. Pretty sure it's negative 1/2 cosine 2 theta. So just try doing the derivative on that. You end up with a positive. Keep the 1/2 sine 2 theta. Chain rule 2. You end up with sine 2 theta. Yeah, okay. I don't know why I got so caught up on that. I think there's just too many numbers. Yeah. Too many numbers, I got confused. Okay, so we'll put the quarter out here. You get negative cosine 2 theta evaluated from 0 to pi over 2. So you end up with negative cosine pi plus cosine 0. So you're going to get a plus 1 over here. You're getting a negative 1 over here, which is just a plus 1. So that's 2. So you get 1/2, or sorry, 2 over 4, so 1/2 here. Yeah, okay, yeah, sanity check. Okay, you get a 2 pi here. You get a 1/5 r to the 5th here, or capital R to the 5th, rather. So you end up with K2. Oh, let's put the constants here. The 2's cancel. So it should be, I guess, 1/5 K2 R to the 5th, or I guess pi K2 R to the 5th over M. Am I missing a term? I don't think so. Okay, yeah, trigonometry. Apparently after, I don't know how long it's been since I first took trig, but, or even calculus 1 as well, but these integrals still haunt me to this day, I guess. Of course, you know, that's kind of my own fault. If I didn't want that to happen, I should have just not majored in physics, but, you know, kind of late to say that. Okay, plus 1/5 pi K2 r to the 5th over M. What else do we want to find? 10.5 with a change. So what was the actual question in 10.5? 10.5, all they ask for is use the result from 10.4 to find the center of mass. Oh, and that integral was the center of mass. The end. It says set K2 to 0 to verify, but I don't know what I'm supposed to verify against, and This looks right, I think. If K1 is set to the initial density, right, then, or sorry, not the initial density, the uniform density that we had before, where kind of we just set rho equals to m over v, then the m's would cancel. You'd end up with the 2 pi r cubed over v. And then you put v in, and then you should end up with, the r cubed should cancel. There should be 4/3, so I think that's like, not really sure what exactly would happen there, but I think that's right. We'll just assume that's right. We'll assume that's right for the sake of moving on to the next problem. Okay, so problem number 4. Oops. Taylor from 10.32 or 23. Consider rigid plane body or lamina. Consider a rigid plane body or lamina, such as a flat piece of sheet metal rotating about a point O on the body. Okay, so we have a flat piece of sheet metal that's probably not necessarily square, so it's some arbitrary body, and we have some arbitrary point O on the body that it rotates about. Okay, so if we choose the axis such that the lamina lies in the xy plane, okay, so x, or no, sorry, in 3D usually you draw the y coming towards you. Actually, it kind of depends. You see actually people doing it multiple ways, where x could be coming toward you or y could be, but I've seen it more often like this. Okay, so that which elements of the inertia tensor I are automatically 0? Prove that izz equals ixx plus iyy. This I want to actually refer to. Oh, Brass, you're heading out already? Yeah, sounds good. Thanks for coming by. Take care, stay safe, have a good evening, and we'll see you later. Hey, oh yeah, Mango, welcome back. Said, although I didn't say that people that specifically study ADS CFT correspondence get recruited, I meant that, that's, I think, if I understand it correctly, it's more like that's kind of one of the specific topics you deal with after dealing with or after studying quantum field theory, and that skill set applies to finance. So it's not like you're actively recruited if you study for that, but rather that if you apply having that skill set, then there's a lot of overlap. So anyway, as for an equation that can be applied to markets, again, my rough understanding of the ADS CFT correspondence is again that you glean information about an n+1 dimensional object through its n-dimensional boundary or something like that. So you would think in the idea there being that there might be some way to extract information either through reducing the number of variables that you're dealing with, or the dimensionality of the space you're working with, or increasing. It could vary depending. It could, some computations could be easier being done in one dimension higher, one dimension lower. So some correspondence there would justify switching the dimensionality. Granted, I really don't know much about the topic, so I can't really say what equations might pertain to finance. Sorry, I don't know what you mean by self-organizing map. Yeah. Alright, so anyway, 10.23. Which elements of the inertia tensor I are automatically 0? I'm really not sure. So if you have a lamina, you know, yeah, this I don't know, and I don't think really wondering about it's gonna help. So I'm gonna look at the solution and just try to process the solution to this one. Okay. Oh, come on, Slater. Cut me some slack. Okay, I guess it's time to use our handy-dandy Tor browser to to get extra free Slater views. Oh, let's see, new Tor circuit. There we go. There's one that's loaded, or that's got some solutions left on it. Okay. So we're considering a rigid plane body or lamina such as I guess a piece of sheet metal that lies in the xy plane. Density of the metal can be density of the metal sheet can be written as rho xyz equals rho xy delta z. Oh, I see. It must be the it could be the chronic, or no, I guess it's the Dirac delta in the z-axis. So when z is 0, there is some density there. Okay, so if you integrate the term above, we can get full mass of the sheet. Diagonal inertia tensors are given by that. Okay. The only non-diagonal element that is not equal to 0 is x, y. And you're supposed to infer that just automatically. Wow, yeah. What is this? Some blog. Yeah, sorry, this is a lot. I don't. Well, okay, yeah, interesting. Sorry, I'm kind of just skimming it real quick, but I'm gonna be honest, a lot of the terminology doesn't really make sense. But I'll try to take a look at it when I have time. But yeah, thanks for the link. Yeah. Okay, so let's see. So density of the metal sheet. Okay. What was the point of getting the full mass of the sheet here? We never compute, or we never use mu in our computations. Yeah, what was the whole point of this first step? Okay, you know what? Let me. Where's my thing? Where's my thing? Guess that's this one. Or maybe I recorded it locally. I've gotten a little bit lazy about making local recordings of my classes, but just seeing how unstable the school servers are, I might have to do those again. Oh, something's like. Oh, okay, actually, I realized. Well, hopefully I wasn't leaking audio the entire time there, but yeah, sometimes my capture card likes to take over. But yeah, so hopefully I didn't have some music running on accident or something. Right, anyway. Okay, let's look at this again. Also, man, this thing is laggy. Oh, I had 2 instances of this open. That's why it's so inconsistent. Okay. PC. Sorry, I don't know what PCA is. I don't know the abbreviation anyway. Let's see. So. Okay. So. Diagonal inertia tensors. I guess I should go back and double check. What are the equations? Because I know the inertia tensor had some equation for the diagonal components and some equation for the non-diagonal components. So let's go pull that up. Wherever the hell it went. Where the hell are those equations? Oh, here it is. Okay. Actually, wasn't there an integral form for this? I mean, I guess this is for discrete particles, so we can do the integral form later. Okay. So, what do I see? What are we doing? 23. Choose axes so that the lambda lies in the xy plane. Which elements of the inertia tensor I are automatically 0? So we should try to prove the automatically 0 terms. So, I guess integral. How does this come in? I guess m alpha would instead be like rho. What is it? M alpha. Is m just the mass of the particle? So then we just swap it in with excuse me, rho. Let's see. Yeah, they just swap in rho. Okay. So then it should just be the integral rho times xy or whatever the two indices are. Likewise, this is going to be integral rho times the square of the non-included indices. Okay, sorry, what was this? Principal component analysis. Yeah. Yeah, I mean, it sounds like you have a couple leads on what you want to look for. As usual, I always recommend just going to a professional and trying to get them to help you, but, yeah. Okay, so let's see. So which terms are automatically 0? From 0 to a, 0 to 0, so... Okay, yeah, so by observation we can see that when a z component is included, then, okay, yeah, so by observation, I, x, z, and I, y, z, which, I guess will have a z component which will evaluate to 0, making the matrix element 0. Okay, so we know we narrowed down some information. We know that our inertia tensor, or I guess, yeah, our inertia tensor is in the 3x3 matrix. Yeah, so then we know that xy, so xy and x and unknown yz, so y, wait, which elements did this correspond to? Xy and yz, oh, it's these two, okay. So ixx, 0, ixy, or xz rather. Iyx, iyy, izx, and I think there should be an argument for justifying that the mirrored terms are also 0. Let's see, is there inertia tensor Hermitian? If it's Hermitian, then we can say that it's the inertia tensor Hermitian. There we go. Or can we make it Hermitian? Is there no easy thing like that where I could say, so it's Hermitian, done? No, life is not that easy apparently. Let's see, alright, sorry, what is this? Oh, Konosuba, welcome back. Statistics is used in physics probably a part. Yeah, I mean, right, I took statistics, well, I don't know if you can call that a statistics class. Yeah, I guess I took statistics technically, yeah. PCA through machine learning, yeah, I mean, did I, oh, you were asking, okay, so Mango's asking if I learned machine learning. Yeah, I mean, I took linear, but I don't think we covered, PCA. What was PCA again? Let me see. Principal component analysis. I mean, if you mention it, it sort of sounds familiar, but I don't recall there a chapter being, you know, dedicated to it in the book. So, or if we did cover, we clearly didn't spend much time on it. So, yeah. And apparently, I guess it comes up in machine learning. So, well, I guess that makes sense. I'm not really sure, but yeah, sure. Anyway, yeah, sorry. So I haven't done anything in that vein. I mean, I imagine I will eventually, but hasn't really intersected my curricular trajectory, so to speak, so far. All right. So anyway, I want to use that to justify that x. Let me see, wait. So anything with a z in it, by its, or any non-diagonal with a z in it should just go to 0 by this logic. So xz, yz, as well as, yeah, so I can just, yeah, if I'm using that as my justification, then I can extend this to far more than just two matrix elements. I can just extend it to every non-diagonal besides the, besides xy and yx, yeah. So, yeah, xz, yz, zx, or I guess I should go in order. So, yeah. So then, yeah, izx, izy, is there any other term? xz, yz, so ixy should still exist. That should be non-zero, unless the integral just happens to evaluate to 0. Yz, let's see, so xz, yz, zy, zx, yeah. So those four should be 0 by observation of how the non-diagonal terms of the inertia tensor are or I guess defined. Yeah. I know PCAs because I learned machine learning without most of the fundamentals because I made bad life decisions for you. Foundational math may be boring, but it's important. Yeah, I can certainly relate to that. Were you here earlier when I got stuck on the integral of sine x cosine x, and I was like, wait, is it a fourth or is it a fourth or a half or a, you know, like I sat there for like a solid like 15 minutes being like, wait, is this the right, did I carry over the, did I do the integrate, yeah. Did I do the chain, the reverse chain rule right, like yeah. But yeah, so yeah, unfortunately the things that were mentioned in chat regarding finance or machine learning kind of don't have anything to do with me at the moment. As much as I would like to learn machine learning at some point, it's unfortunately my schedule is pretty packed as it is. Yeah. Actually, one thing, so I don't know if anyone goes on or browses Reddit as much as I do, but one thing I did realize, or one thing I did think, every once in a while there's a, in fact, you know, it's 9:43. Let me take a quick break. So, one thing I thought, there's always every once in a while on Ask Reddit, there's a thread about like, would you take $1 million to be, totally cut off from human contact or whatever? And it's not always $1 million. Sometimes it's $10 million. But the one I saw recently was something like $1 million. And the conditions in the thread were that you're allowed to use the internet and you're allowed to access resources. You're just not allowed human contact. So if you watch videos, for example, you can't watch live streams, right? But you can you can watch regular YouTube uploads, but you also just can't comment on them and stuff. You can use websites, but you can't use any commenting system or whatever. And I was thinking about it, and I was like, I personally think I could probably survive a year. I think maybe more than a year, maybe going 2 years would be a little bit tough, but I could definitely do a year. And I realized, and I was thinking, like, I wish someone would actually do that, like, instead of just making an Ask Reddit post, because I would totally just use that time to just go back and do, like, all my fundamental, like, math, physics, chemistry, biology. In fact, I would use that chance to freaking learn anatomy properly this time around, right? Because you got a whole freaking year, right? Like obviously, I probably can't realistically do all of it, but I think I could probably nail calculus if I had a whole year dedicated to it. Yeah, I'd have to be careful about it because time flies. But like, I kind of wish that someone would do an experiment like that, because I would totally agree with it. If I get all my like basic needs met, and it just gives me an excuse to just do whatever I want. Yeah. Of course, again, over a year, any longer than a year, I think would be a little bit tough mentally, but I think a year is achievable. If those Ask Reddit posts were like 5 years or something, then I'd be like, yeah, that's 5 years is a long time. SDE. Sorry, I don't know what SDE is. I mean, I guess I know an SDE, but I don't think you're talking about that SDE. So let's see, because that was an anime. But anyway, all right. So we know that these terms are that. We also know by observation that let's see, also IXY must equal IYX just by observation, because all you're doing is multiplying by XY or YX. Stochastic differential equations. No, I don't even know what stochastic means. Although one thing I've thought about the word stochastic is, what's that? Like there's a education like book publisher that's what it's like Scholastic, I think. Is that what they're called? Scholastic? Yeah, I think they're they do publishing for like educational books. And I always thought that the two sounded so similar, stochastic and scholastic. Wow, the first sentence on Wikipedia kind of provides you with no information. Didn't they teach these people how to like write definitions? A stochastic differential equation is a differential equation which one or more of the terms is a stochastic process resulting in a solution that's also a stochastic process. Don't use the word in the word as part of its definition. I know, though, you just have to go look up what stochastic means, but yeah, anyway. Like, didn't these people learn in in 5th grade English, don't use the word inside its definition? Like, I know, it's just a matter of going and looking up what stochastic means, but like, still, I'm like... Anyway. But yeah, sorry, the name doesn't really ring a bell. Or the name rings a bell, but I'm pretty confident we didn't really study it. To make it does some random thing sound better. Oh, you should have mixed in like entropy or some bullshit like that. And of course, that's more of a statistical process, so I guess that it's not totally random, but yeah. Yeah, but yeah, sorry. So anyway, I have no, I don't, the specific subtopic doesn't really ring a bell. Entropic variance, okay. Stochasticity, that's so, wow, man, imagine saying that in like, in real life. The stochasticity, that's, wow. I mean, I guess you sound really cool because you can nail the word, but like, yeah. Anyway, all right. So okay, so basically narrowed it down to 4 integrals. Then it's the integrals for the diagonal terms x x y y z z. I think z c should just be. Uh, Wait a sec. Yeah. Z z is gonna be. Hmm? The diagonal terms are. Oh right. Yeah. X x and y y are gonna have a term z squared in it, but that's just adding z squared to the inside of the parentheses, so that won't zero out the entire term. Yeah. Okay, so let's see, the other terms are, and so the xx term of the inertia tensor is going to be integral rho, in this case y squared plus z squared d volume. No, wait, no, this is a. Inertia is a rank 2 tensor, right? So this shouldn't be a d like dy dz. I guess it should just be dy dz. Or I think inertia is inertia a rank 2 tensor? Wait, let me think. Oh, maybe it is xyz actually. Don't call me on that. I don't remember. I'm barely paying attention in class as it is. Integral of sine. Well, actually, no. What I said earlier was that I blanked on evaluating the integral of sine x cosine x, essentially. Well, it was sine theta cosine theta, but I was blanking on it because I was like, okay, so you do the double angle and then you integrate it, and then I was like, I got a little confused on how many chain rule, like, or anti-chain rule, I guess. Is it called anti-chain rule? I don't know, but you guys know what I mean. And I forgot how many like anti-chain rules you had to do, or like, or which came from. Yeah, double re. Yeah, no, I got mixed up because I was like, okay, you get because if you do sine x cosine x, right, so you have to do the 1/2 and then 1/2 integral to sine x cosine x, right, and then you'd use double angle, so you get sine 2x, right, but then you integrate it and you get cosine 2x. Oh, sorry, that hit the microphone. But then you get integrated, you get cosine 2x, and then you have to do anti-chain rule, and you get the 1/2 out of it. And I was like, wait, how many 1/2s are there? I was like, is there 2, or is there 3, or is there 1? I got mixed up. But anyway, so it ended up being 2 if you start out with sine x cosine x. But I was like, I got so confused on that. And the funny thing is, I distinctly remember back in calculus 1 getting confused on the exact same integral, just because I was like, it was exam time and I was so confused. I was like, how many 1/2s are there? How many 1/2s are there? Anyway, so yeah, right. Okay, so dx dy. Why is there delta? I guess it is dx dy dz, and that's why they go through the trouble of defining the mass, or the density of this lamina, as rho xyz equals rho, or delta xy, or whatever this is. Oh, it's because the starting function wasn't 2 sine x cosine x. It's because the starting function was sine x cosine x by itself. So to make it into the form 2 sine x cosine x, you had to multiply by a 1/2 in the beginning and then throw a number 2 in the inside, right? So that's where the second 1/2 came from, I think. Or did I do that computation wrong? Yeah. So the starting function was regular sine x cosine x. So I needed the 2 to bring in. Yeah. Oh, and did I say negative? Did I say negative cosine x or cosine? Well, you get the point. Yeah. Well, no, I think you did it right, because if you start with 2 sine x cosine x inside the integral, then you do just end up with 1/2, right? Yeah, it's if you already have the number 2 out there, then your life is fine. It's just I didn't, so I needed to also do a 1/2 2, or sorry, 1/2 times 2 times the thing, right? So I just get, but exactly, that's what I mean. It's something so simple, right? But I was like, wait a sec, like I'm not smart enough to be able to do this by intuition. I got to stop and slow down and, like, make sure everything. And I was like, how many 1/2s did I generate again? I can't remember. It was something like that. But anyway, do you use substitution? Do you have to use substitution? I mean, I guess you can substitute 2x for some u, and then du should just equal. Hmm? Oh yeah, I guess you could do that, right? Because if you do 2x equals u, then you get 2 dx equals du, and then you should also be able to generate the right 1/2. Yeah. So really, that's what I guess I should have done. But no, Konosuba, I'm pretty sure you did it right. It's just I should just write it on screen. But anyway, but no, you did it right. Yeah, can't follow. Oh, so sorry, I think it's 10 o'clock. Okay, yeah, that's fine. I have some time. Right. So oh, okay. Let me try to connect it. The screen. Sorry, the screen mirroring, as you saw earlier, it's really kind of picky about connecting. But yeah, so all I'm saying is that, or I guess Konosuba can type it, but the TLDR is your starting integral is going to be like sine 2x, with the integral being in terms of, or it's going to be sine, you're going to have an integral sine 2x with measure dx, right? And then you can just set the inside of the sine, the 2x part, equal to some new variable u, for example, right? And then so then you have integral sine u dx. Of course, you don't want it in dx because you have the variable u, right? You want to switch it to du so that you can actually evaluate the sine function as a function of u, or evaluate the integral of the sine u function anyway. So then for that, you would, you could take, for example, 2u, that thing you said earlier, and then you can just take 2u equals x, that line, and then you can take the infinitesimal kind of version of that, which is just going to be 2 du equals dx, or sorry, 2 dx equals du. Or, oh, is that just typed up? Is it? Wait, what is that? Oh, that's convenient. Yeah. Okay. Yeah. So that literally that. Yeah. But yeah, exactly. So the cosine squared thing, I don't know. So the thing is, I couldn't do the mental jump to cosine squared, but yeah. So TLDR, that's the way to do it. Although I know it's just a matter of like using. There's that one identity that I can't remember. I can't remember any of the trig identities, so I have to do it one step at a time. But anyway. Yeah, so anyway, what was I doing? Right, I was doing the inertia tensor. Yeah. So no, let's take what they did here. We're gonna set rho xyz equal to some other thing. I guess this is delta xy, some function for how the frickin' Lamina's density works. But then we're gonna put in a Dirac delta for z here, just to say that if we sub in the function now, we get delta function of xy times the Dirac delta centered at z equals 0 times the function y squared plus z squared dy. Or sorry, z squared dx dy dz. And well, that will just give us then the integral delta xy Dirac delta z for I guess y squared dx dy dz plus integral delta xy Dirac delta is centered at z equals 0, z squared dx dy dz. Of course, noting that, did I do this right? You evaluate it, you should only end up with this right term. And we want to evaluate over symmetric bounds. Beta rate should just equal 0 except for 1 at the center. So why doesn't this term go to 0? Oh, here we go. Yeah, okay, so here's the justification then. So you first evaluate the dz integral. I don't know. You'll evaluate, okay, so the first one here, you have delta xy, Dirac delta z, y squared dx dy dz. You evaluate the Dirac delta, you end up with the function 1 times xy, y squared dx dy, just by the property of the Dirac delta, right? You're evaluating it essentially at that 1 point. So at that point z equals 0, you have value 1 for z. Anyway, this one over here, we have a function of z in here. So what ends up happening after evaluating the Dirac delta is we get delta xy. The Dirac delta goes away. We have a function of z squared evaluated at the point in question, which is 0. So then that entire integral goes to 0. So this term just vanishes. Okay, there we go. There we go. That's what it is. So then we get delta xy, y squared dx dy as our function. I don't think we can evaluate it any further than that without actually knowing the density. Yeah, we're not given the mass distribution, so yeah. We're not given the mass distribution, we're not given a tangible density, we're just gonna leave it alone. Okay, so Iyy is the next one. It's gonna be integral rho, so it's gonna be rho, and then since it's yy, we're gonna take x squared and z squared, since those are the indices not included in the diagonal, or in that spot on the diagonal, so it's dx dy dz. And then again, we're gonna dump in rho equals delta xy times Dirac delta z. That's multiplied by x squared plus z squared dx dy dz. And gives us two integrals, delta xy, Dirac delta z, x squared dx dy dz plus integral delta xy, Dirac delta z, z squared dx dy dz. Okay, so then we're gonna do the easy one. This is gonna be the integral x or delta xy, z evaluated at 0 squared dx dy, so that just goes to 0. This guy over here is going to be delta z just equals 1 then at that spot. So xy, x squared dx dy. Yeah. It's really weird in that sense, right? So the Dirac delta goes to 1, or wherever z is centered. And then all the other z functions get evaluated essentially at that single spot. It's always a weird function to have to remember. But anyway. Alright, it's a bit tedious, but we're going to quickly do the zz component of that as well. It's going to be x squared plus y squared dx dy dz. Integral delta xy Dirac delta z, x squared plus y squared, dx dy dz. No need to separate it. We're just going to leave it. So we're going to get delta xy, x squared plus y squared, dx dy. Iz, z. Is going to be that term. And I need more pages. Add page. Come on, add the page. I need the page. Hello, there we go. Again, I think we're also missing the ixy term, which is, where is it? It's going to be the negative integral of rho xy then. Dx dy dz. Negative integral delta xy Dirac delta z xy dx dy dz. Okay, negative integral delta xy times x times y dx dy. So that should be all our terms. All right, what else was the question asking for? Okay, so which of the... Oh, I didn't need to prove that. Shit. I didn't need to determine what the xy or the yx term was. Shit. Whatever. Anyway, whatever. So in total we get so I guess technically this is my answer. Okay. Sorry, what is this? Wait, why does it become sine 2x? Oh, is it about the PDF? That's just a trig identity, right? Or I don't know which part you're asking about, but I'm pretty sure it's just a trig identity, probably. It's usually just a trig identity. That's the thing about trig. If something weird happens, usually it's some weird trig identity. Yeah. Anyway, okay, so we wanted to prove that okay, so we also want to prove that, so let's call that part A, call this part B. B, we want to prove z equals ixx plus iyy. So then we're just going to copy paste from above. Izz was this integral, and I imagine it's literally just the integrals add up to each other. So yeah, so that should equal then ixx. Ixx should only have one term with a y squared in it. Yeah, because z is 0. And then iyy should also just have an x squared term in it. Sanity check, yes it does. Okay, so then the sum is obviously equal to izz, which has both an x squared and a y squared term in it. Yeah, and all other terms are equal, so integral xy, x squared plus y squared, dx dy equals integral delta xy, y squared plus x squared, dx dy, thus has been proven. I'm not actually writing this has been proven, that's so embarrassing. Just use the black square. Have you seen people actually write QED on their proofs? It's kind of embarrassing, right? like I know when the proper way to use it is, but even then I just don't like to write QED. It just sounds so like pretentious. But I know it's the right way to do it. Yeah, wait, do you actually use QED? The thing is, I just seen people use QED on like everything, and instead of just when you're answering a question, and it's just like, like I don't know, it's just I don't know. I know there's the right way when, and like I know that there is a right time to use it. It's just it looks so, I don't know. Oh, okay. So right, like so I don't know, but I just yeah. So I'm not talking about like that. I mean like on their like homework answers and stuff. And like so okay. So maybe it's different for competitions, but I thought again. So my understanding was that QED is only used for when you have a question or when you start with a question like is this the case or is this is this true, and then through the proof you answer yes or no to that, and when you answer yes or whatever, when you answer the question you write QED. Like that was my understanding of how it works. And if it's just like prove this property or something, then you just use the black box to say like thus I've this is the completed proof. Like so that was my understanding, but I could be wrong, especially if there's like there might be like competition specific language and stuff which I don't know anything about. But I've seen some people like that are I guess really proud of their physics skills, and I'm like, I mean, I guess they're smart. So write a triangle. Oh, I've never heard of the triangle. What does the triangle mean? Is it the same as the black square, or is there a different nuance to it? Meanwhile, if you're I don't know if you're answering that, but in the meantime, um problem number 4 was that, I think, right? So I could be lazy and I could just skip problem 5 and just accept the time or the um I could just be lazy and just be like, I'm tired, I just want to go to sleep, which I kind of do want. Pretty much the same thing in most cases. Okay, okay. Hmm. Well, I'll keep using the black box, but I'll keep the triangle in mind. I've never seen the triangle, but I mean it must exist. So QED equals triangle. Really? Okay. I'm so confused. So I gotta double check what the difference between all the symbols is because, yeah. Anyway, they're interchangeable, really? Huh? Okay. Well, I guess that explains why I've never seen it because I rarely see questions like posed as like like is this proof or is this property true? I've never seen stuff like that. It's usually just like just prove this property. So I guess that's why I never see QED or triangle really. Um, I mean, I guess I do see it. I just don't like not in the textbook usually as a question. Okay, so problem 5. As you know, formaldehyde is a trigonoplanar molecule. Oh crap! Now they're bringing. Okay, it's just formaldehyde, right? So it's not totally into organic chemistry because formaldehyde is just a basic. Uh, hmm? Does formaldehyde qualify as a ketone? Let me just formaldehyde. I mean, it's got freaking aldehyde in it, so I would expect it to be an aldehyde. But wait, I thought aldehydes were RC double bonded O with an H on the end. Can that R just be another hydrogen? Because then it would be, what's called formaldehyde. It must be an aldehyde, right? I could be wrong. Yeah, that was kind of a dumb question. It must be an aldehyde. It's freaking got aldehyde in its name. But I thought aldehydes had to have I got to go back and learn organic chemistry then, clearly. All right, so whatever. You have a formaldehyde stuck in the YZ plane, I guess. Okay, in this problem, we study a single molecule of formaldehyde using classical description as a collection of point masses, one for each atom. Center mass is at the origin. Okay. At t equals 0, the molecule is in the YZ plane as shown in that diagram. Okay, see, they for once they give us a diagram, Let's see. So we got a formaldehyde. And this is something that I think they want us to be careful about. But the carbon is not the center of the molecule. And this just by observation. You would expect the double bonded. Actually, wait. How does the how does double bonded oxygen with carbon compare to single, like a hydrogen and a carbon bond? Because you think, well, obviously the CH bond is going to be pretty close, right? But the C double O or double bonded to O bond, that should be pretty close as well. Which is shorter? Someone could look it up. FX trading. I don't know what that is. I've heard that it's really scary, but or that was, I guess, 4x. Is FX and 4x the same thing? I don't know what that is, but okay, so we use M as the mass of the hydrogen and atom. So hydrogens are mass M. Foreign currency exchange. Oh, I see. Okay. Is that so? Is that the same thing as 4x? I guess that must be what 4x stands for. Yeah, no. The only only place I've heard 4x is in like I don't remember. I just remember seeing the term used on Nico Nico Doga a lot about like people that would like gamble all their money away in like really dangerous investments. It's just that you got that stereotype. Kurwa? Kurwa. I'm gonna call it Kurwa from now on. Okay. But okay, so 12M and 16M for the other two atoms. So obviously oxygen's gonna be the 16M and carbon's gonna be the 12M. We assume that the HCH bond angle is 2 pi over 3. So this total is gonna be 2 pi over 3. So we expect this each of these to be pi over 3. So I guess the angle's maybe a little bit wider than what I've drawn. Oh, is the default Polish square? Oh, okay. Thank you for letting me know. I didn't know that. Okay, so we're not going to use that word. Yeah. if someone understands Polish, I apologize. Yeah. Where do you even learn stuff like that? We use D for the distance from the hydrogen atom to the carbon atom. Okay, so these are going to be D. And then for simplicity, we use the same value for the distance from the carbon atom to the... Really? I mean, obviously they're going to be slightly different. I didn't think that they'd be different or close enough that you could estimate the distance from the carbon atom to the oxygen atom, the same as carbon to hydrogen. I mean, I vaguely remember their signature being very close, or not close, but like in the relative broad same, like, chunk on like an IR spectrometer, but like they weren't so close that you couldn't identify them. In fact, the only time that you'd get ambiguity there is if you had a massive like carbon chain, because if you had a massive carbon chain and your molecule wasn't linear, then actually wait, no, those are CC bonds, so that's even, yeah, right. So I don't think, whatever, so they estimate it like that. The TLDR of that was, I was just saying that the CC bonds, if you end up with a if you end up with like a molecule that's folding on itself, and a lot of the fold is facilitated by a long like carbon chain, then the carbons at the basically at kind of the bending point, so to speak, as it's bending, are going to be a little bit farther because they're kind of just getting pulled. So that signature can look close to that signature can like blur into other like bond signatures. So that's what you have to watch out for, or that's one thing you have to watch out for. But again, I don't think you can, well, whatever. So they estimate the distance from each thing to be the same. Because every Polish person in a talks like this, every Polish song has it, every Polish streamer says it, but most importantly, Poland blood. Okay, admittedly, I haven't read a lot of Poland Ball. In fact, this is something I really want to do, but I really think like you know how there's like a lot of VTubers that do like Reddit stuff. I think the next big VTuber thing to do is like Poland Ball translations, or like even better, XKCD translations. I think that's the next big thing for like Japanese VTubers. Yeah. Because XKC is like so relatable, right? To be fair, to Poland Ball needs no translation. well, you know what I mean. But yeah. I think that's gonna be the next big thing because those are like hilarious. Granted, I've only read a few of them, but then XKCD is just also just so relatable, right? Like, so I think that's gonna be the next big thing. Anyway, okay, so I gotta actually focus on doing this. Or I can just skip it. You know, it's already 10:20. I can just no, I'm not. Um, we're gonna struggle pathetically and try to finish as much of this question as possible. Just native language replacing nouns in bad English. Actually, you bring up a good point. That'd be kind of hard to translate, wouldn't it? Well, give it a try. We'll give it a try. Um, I guess that'll be Operation Yago season or Operation Meet Yago season 2 then. I think season 1 we've already got so much stuff that I can't possibly feasibly finish it all in time. But season 2 will be like, you know, doing all the leftover stuff or all the other cool stuff. All right, so calculate the coordinates of all of the atoms in the diagram above. Okay. So we need to do the center of mass first, right? And we do the center of mass using the discrete sum definition, not the integral because we're doing point masses, right? I think. So where's that equation? Where's the equation, please? Where's the equation? I can't remember all this shit. Okay, principal axes. Now that's a little bit before that, I think. I'm really tempted to do the XKCD thing, though. Of course, I say I'm tempted to do a lot of things. Do I realistically have time to do all of them? No. So really, what I'm trying to figure out is how can I possibly streamline the process so that, you know, I can be like, oh, I can quickly make something, not, oh, I need to dedicate 6 hours to sit down and actually record it. So I think a lot of this is going to be research into figuring out how to streamline the video production process. I have some ideas, but where's the equation? I mean, I guess we have the position of every particle, right? Oh, relative to each other, actually. I don't know where they are relative to the center. But that's what that equation was supposed to be for. From that, we could get the center of mass position. Obviously, we should have XY symmetry, or sorry, we should have symmetry in the on both sides of the z-axis, but and likewise in the well, it should be at the middle, basically. Yeah. So where is that equation? Near. This is the inertia tensor or moment of inertia tensor. Where's the center of mass equation? You know what? We're gonna use the forbidden tool, aka Slater. We're just taking the equations, you know. No hits. Okay, we're fucked. Then we'll just look up the, let's see. Just look up the equation manually then. Center of mass, point particles, point masses, I guess. Probably should have started there. What was the equation? Actually, wait, yeah, actually, I don't need some of that information, actually. I really just need the vertical information, don't I? So is this right? Is the equation right? R equals 1 over m times the sum for each particle times the position vector. Yeah, okay, so we're gonna, so let's just calm down. So coordinates of all the atoms in the diagram above. What coordinates do we actually need? We actually don't need any information about the, well, actually, yeah, we don't need anything in the y dimension because we know the angle between the CH or the HCH bonds, so we can get the y dimensionality. We know they're all flat in x, so let's see. Yeah, so let's start with that. Calm down. No need to rely on solutions just yet. Or so he says after looking for solutions and not finding any. Let's see. By observation, x naught equals 0 for all particles. Likewise, we know that y naught equals 0 for oxygen and carbon. We also know that y naught for hydrogen is going to be pi over 3, or plus minus pi, what is this? The angle's there, so it's going to be the sine of pi over 3. Oops. Okay. Plus minus sine pi over 3. Okay, so all that's left is the z component. That's all we really care about. Okay. So we're going to need to know the center of mass for z. So for z, we first need the center of mass, which is going to be 1 over m, or in this case, m is the total mass, yeah, so times the sum from I equals 1 to n, however many particles there are, mi times zi. Oh wait, isn't this backwards? Don't I need... Okay, whatever, so capital M, that's just going to be the sum of the masses, so that's just going to be 1 m, or it's going to be m plus 12m plus 16m, should just be 30. Lowercase m is capital M. Right. We don't know the z center of mass. I also don't know the z of each. I guess I just have to project it onto like a plane where it is centered about the carbon. Okay, so then get 1 over 30m times the sum. Okay, so it's mi, so we get the, okay, so we get m hydrogen times zi, which is going to be, actually let's see particle, let's number the particles. Okay, hydrogen 1 is going to be 1, hydrogen 2 is going to be 2, carbon 1 is going to be 3, oxygen is going to be 4. Okay, so number 1, number 2, number 3, number 4. Just want the sum of all of them. Yeah, nice and simple. I actually pushed my Pico CTFs. Oh shit, because that competition's still going on, right? Oh. Okay, yeah, shoot, man. Wait, does I thought GitHub lets you have private repos now for free. Yeah, shoot. Well, it's a good thing that they let you know before you publish some of the some of the more problematic ones. Oops. Okay. Oh, they do. Okay. Oh, you just forgot to say. Okay. Oh, I see. Oh, shoot. Okay. Yeah, it's good that they let you know. That would have been. Well, you would have certainly helped out the better teams, wouldn't you? But they're automatically tracked. I mean, I guess that's smart. You'd think a cybersecurity competition would do that, but yeah, I mean, that's pretty smart. Yeah. So I got message in 2 minutes. Oh, that's fast. Wow, actually. Are they up at this time? It's freaking like 10:30. Go to sleep, right? I mean, it's good that they let you know, right? Yeah. Oh, I don't know about you, but I would totally get like a cold sweat if I just suddenly got messaged out of the blue by the mod, like the competition like staff or something. Yeah. Oh shit. Well, that one was scary, but at least at least it wasn't. At least it didn't get out of hand. Yeah. Right. So we want the mass, which is just gonna be m times. Got one serious automated email and another one from mod. Okay, so thankfully they're not just going full like banhammer crazy about it. They actually have some staff kind of looking over it. Yeah. It sounds. Thankfully, he was chill about it. Okay, that's good. Oh man, that's kind of hilarious, actually. Yeah, might not want to give out the answers while the event's still running. Yeah. Maybe they're thinking like, holy shit, this guy's so confident he doesn't even care about giving away the answers. Like, talk about the like the talk about the talk about asserting dominance on all the other yeah, seriously, talk about asserting dominance on all the all the other participants. uh, like I can give you these answers, no sweat, still gonna. Okay, and then this is just gonna be at position. How do I label its position if it's at position 0? Well, actually, I guess if I set the axis at 0, then the thing at position 0 should have no contribution to the. Actually, no, it should. What am I saying? No, of course it should. So d cosine. Did I put the d cosines here? I guess it's a d sign there. Okay, d cosine will give me the height in the bottom direction. This will give me d cosine. Or no, this will just give me d 16m. So 16md for the position of O. And what am I missing? Just the warm up and the packet capture problems. Okay, I mean that sounds pretty tough as it is, but the hack box. Oh, apparently there's a lot of websites. Okay, good to know. Or am I just supposed to choose some position offset from everything? Well, then that doesn't make sense either, because then something has to be x equals 0. Okay, sorry, I need to do a sanity check because I'm like, why does this should be 0, but I don't think you should just be able to 0 out that term. So we're gonna do an embarrassing sanity check, which is just center of mass point masses. Because somehow I'm missing something that I feel like should contribute to. I like the equation is right. I had this. I'm pretty sure the equation's right. Oh, dude, Konosuba, thank you for reminding me. I don't think that was intentional. DEF CON. I think sorry, this is part of Operation Meet Yago. But another thing that I definitely wanted to cover, that freaking DEF CON talk with the dude that tells you you can use the traveler's hook to shim like doors open. That traveler's hook is so freaking convenient. I wanted to talk about it. So okay. Thank you for reminding me. Because I've been meaning to talk. That tool is just so convenient, and it's not even used for its intentional or its original purpose, right? Like, yeah. Okay, so I guess you guys are doing pretty cool stuff with hacking there. I don't understand any of it, but okay. So give me the example with multiple particles. Oh, okay. So yeah, the 0, that feels so weird. So the item that you set on the 0 position is, or on the 0 of the what do you call it, of the plane you're working in. That feels so weird, but I mean the math works, right? So you know what? Okay, last sanity check. So if I do this, then I should basically end up with the same value, no matter where in the axis I set these things. So technically, I should end up with the same amount, even though I feel that that doesn't make sense. Okay. Anyway, okay. So what do we get here? We get 1 over 30m, which equals what's cosine of pi over 3? That should be that's a known one, right? Let me think. Pi over 3 is the big angle, right? So the cosine of the big one is the short value, right? So I'm thinking that's 1/2. Is that right? Yeah, it's 1/2. Okay. So 1/2 d, this is going to be m negative 1/2 d. 12, it's going to be 0, and then this is going to be 16 md. So this is going to be a negative 2, or sorry, it's negative 1d, or negative 1 md plus 16 md. So then we get 15 md over 30 m, which equals 1/2 d. Really? Okay, so sanity check. So then if I change the axis, then I should get the same value, or the same relative position. I shouldn't get the same value, but I should get the same relative position of the center of mass. So if I set the axis instead to, say, where the hydrogens are at the bottom, these are d, d, d respectively, and these interior angles are pi over 3. Okay, sorry, I can't keep up with chat, so you guys have fun. I guess. I don't know. Okay, so then the center of mass should just be the sum of m in their x positions, In this case, we have 0 plus 0, and then, or sorry, 1 over 30m. And then we should have 0 plus 0, and then carbon should be at here. Okay, so at the cosine or d cosine pi over 3 again, we should have carbon, which is the 12m mass. And then in addition to that, we should have at the d plus d cosine pi over 3 position, we should also have the 16m mass. So then we get 12 md cosine pi over 3, which should just be 1/2. So you get 6 md from that. And then from here we get 16 md plus, and then 1/2 d. So we end up with 3/2 d times 16. So we're going to get 24d, 6 md. So we get 30 md divided by 30m. So we just get d. D would be the position around here, which is going to be okay, it's going to be d minus what? Oh, it's d minus d cosine pi over 3. So that's 1/2 d from, so these are 1/2 d essentially. Then that feels so weird. Their height is 1/2 d. I mean, I guess if they were at 45 degrees, they'd be rad 2 over 2. So obviously it'd be like a weird thing, but they're exactly 1/2 of d, not some. This height is exactly 1/2 of d, which I guess makes sense. It's not this height. Yeah. Okay. Yeah. Okay. So then, I don't know if the sanity check necessarily worked, but all I know is my intuition totally sucks for this kind of thing. Okay. So then, it's 1/2 d above the c. So let's see. So recentering the diagram, it's 1/2 d positive. So it should be right here where O and C double bonded. Right in the middle is, so this total length is d. This is 1/2 d. And then these are at pi over 3 from each other, and with length d. So these are d1/2 d. I think earlier, before I erased it, I got total d, so that makes sense. So okay, so the sanity check basically did work. I am sorry for it. Okay. So the positions of the atoms are, let's see, hydrogen 1, and I'll just label 1 and 2. I wonder if well, I was going to say hydrogen 1 and 2 are indistinguishable, so yeah, I just realized, both in a quantum mechanical sense and also just in a physical sense. If you have a formaldehyde, you can't tell which way is up and down, right? So both in a quantum mechanical sense and a literal sense, you can't distinguish the particles. I guess those at the end of the day really are the same though. So okay, so it's gonna be in the negative. So the x, wait, what dimensions are? Okay, the x is coming out of the page, so they're all x equals 0. The y is going to be positive or negative d sine pi over 3, and the height is going to be negative d. Or it's going to be negative d, negative quantity, excuse me, 1/2 d. D over 2 plus d cosine pi over 3. Carbon is just going to be 0 in the x, 0 in the y, and then it's going to be negative d over 2. And then the oxygen is going to be 0, 0, positive d over 2. Okay, so that gives us all the coordinates. Calculate the... Okay, so... Oh man, there's so many steps. Ugh, I don't want to do this. Moment of inertia tensor. Okay, we know how to do this for discrete particles, yeah. So let me get another drink, and we'll take a look at chat. Lotka Volterra models. Oh, now there's a word that I'm familiar with. Import a TensorFlow model. Okay, yeah. Okay. So I'm just scrolling through. I don't know what SVM is. Something about NDSS. Don't know what that is either. It's about job prospects. Okay. Yeah. Yeah. Okay. Cool. All right. So now I can't. I can't stop running away from the reality of my assignment. Got to get back in here. Okay. I got one. This is the last question. I've done number 6. So, and I've done 1 through 4. I think I'm pretty confident with the answers for number 1 through 4. And I actually would like the way they did it this time around, because I think they know that people like me are probably just going to look at the solutions, just purely out of necessity for or out of the time restriction to solve these things. So they're doing do this example or do this question, but add this twist to make it a little bit more complicated. And I'm like, that's totally fair. You get a template, so you get kind of the feel of how to do the problem, but then you get the twist to actually make it relevant to the class. Like I like those kind of assignments. Okay, I totally missed where this equation was, but it's the computation for the inertia tensor, but for a system of particles, or a system of discrete particles. So where is that? I know it's somewhere here. Here it is. Right. Yeah. Are we doing the inertia tensor? Yeah, we're doing the inertia tensor. Okay, so I equals Ixx, Ixy, Ixz, Iyx, Iyy, Iyz, Izx, Izy, Izz, and we're noting that Ixx is equal to the sum of each particle's mass times the times the position times the square of the square of the components that are not in the indice. Okay, for the diagonal components. And for the non-diagonal components, it's the negative, and we did this earlier, but I did the integral form, negative sum of the mass of each particle times the index, each component in the index, yeah. So that's gonna be x alpha, y alpha. Okay. So for that's a lot of computations. But I think the argument is we're supposed to use symmetry, or else this gets insane. So symmetry, what can we say? I have no clue. I have no intuition for this shit. Let's go look at the video. He talked about this. I'm starting to build kind of a taste for cranberry juice split with sparkling water. I didn't really like cranberry juice before, but I'm starting to grow to like it purely by virtue of that being like one of the only juices that they offer. Known inertia tensor about the origin. They're saying xz. I think the problem is that when I see the ixz or ixyz term of the inertia tensor, I'm like, I can't visualize what that matrix element is supposed to be. Like is it a spin around something, or is it the? Am I supposed to be looking at the plane, or? Like, it's not the I don't think it's the actual rotation or the actual like vector or anything, because it's the element in the matrix. So if you got like the eigenvalues of the matrix, for example, I can see how you could then determine the actual vectors, the actual like inertia, like yeah, like but that's not what we have. We have some like precursory matrix. So I have no idea about the intuition. I think I'm just going to brute force it. When in doubt, brute force. It sucks, but it's just what you got to do. Oh, okay, Mango, it sounds good. Thanks for coming by. Take care, stay safe. Have a good evening. Yeah, see you later. Thanks for coming by. It's me. I also want to hit the hay soon too, but I think I'll go till 11:30. Yeah. 11:30, we'll do as much as I can. So we want the sum of each particle. So ixx, that means I guess we want the m alpha. So this is supposed to be like m1, or I guess mh yh squared plus zh squared plus mh, I guess 2, h1, h2, yh2 squared plus z h2 squared plus m carbon, y carbon squared plus z carbon squared plus, that's a lot. That's a lot of computations. I can see why they want you to justify with symmetry to reduce the number of computations you have to do. Of course, that depends on if you have the intuition to do that, and I don't. So, there. That's life. Alright, so the mass of the hydrogen is going to be lowercase m, lowercase m, lowercase m, lowercase, or no, carbon's going to be 12m. Oxygen's going to be 16m. You have y squared. y squared for the hydrogen is going to be plus or minus d sine pi over 3. So if we just label the left one as 1 and the right one as 2, then the left one will be negative d sine pi over 3. Okay, so negative d sine pi over 3 squared plus z, which is negative d over 2 plus d cosine pi over 3. You know what, let me evaluate those. Okay, so d cosine pi over 3, that's the short end of the big angle, so that should be 1/2. So this should just be negative 1. And what is the opposite? Is it rad 3 over 2? Is that right? Sine pi over 3. Is it rad 3 over 2? Yeah, rad 3 over 2. Okay, awesome. Wait. Did I have those backwards? Pull up should I just have a unit circle like posted to my wall from now on? Pi over 3. The sine component, yeah, is rad 3 over 2. Okay, yeah. So sanity check, yeah. So I guess minus plus d rad 3 over 2 and 0. Okay, there. That makes our lives a little bit better. So the y component of particle 1, that's going to be, oh, and we have a square, so the the square root, is it? It's rad 3 over regular 2, right? This is what happens when you don't do well in trig. It's rad 3 over regular 2, so squaring that should be 3 over 4. Oh, sorry, 3 over 4. Okay. Negative d rad 3 over 2 quantity squared plus negative 1, or negative d quantity squared. Positive d rad 3 over 2 quantity squared plus negative d quantity squared. Carbon chung is going to be have a y component of 0 because, or no. What did I do wrong? No. Or no, it is. Yeah, because it's centered, yeah. The z component's not 0 though. That's going to be a negative d over 2. And then the oxygen also has a y component of 0 and a z component of positive d over 2. There we go. d の2乗4分の3プラス d の2乗d の2乗4分の3プラス d の2乗 12m d の2乗4分の d の2乗、やっぱそういうところって癖が出るんだね。 d の2乗4分の d の2乗ってこと。 Okay, so 4分の4だから7 fourths md squared plus 7 fourths d squared plus 12 fourths d squared, or md squared, d squared plus 16 fourths md squared. You end up with 7, 7, that's 14, 30, 42 over 4. Yeah. I guess we'll just call it 21 over 2 md squared. Xx as one term. What? No, that's not where I want the page. There. Okay. Alright, okay, so Martian tensor xy, or let's do the diagonals first for convenience. Yy. H1, it'll be x squared h1 plus z squared h1 plus mh2 xh2 squared plus zh2 squared plus carbon x squared carbon plus z squared carbon plus oxygen x oxygen squared plus c oxygen squared. Okay. Alright, so we just put m for mass, m, 12m, 16m, x hydrogen. So the x's should all be 0. None of them have an x term. None of them are out of the plane. But they all have non-zero z terms. That's the pain. So z for hydrogen is going to be negative d. So that's going to be negative d squared, quantity squared, negative d quantity squared. Carbon z is going to be d over 2. So negative d over 2 quantity squared. And oxygen is going to be positive d over 2. Quantity squared. Okay. So we have d squared m, another d squared m, we have 12m times d over 4, and we have 16m d over 4, or d squared over 4. Okay. So we end up with, this is just 3md squared. It's just 4md squared. It's just 1md squared. So that's 1, 2, 5, 9. 9md squared. Okay. Alright, so the zz term is going to be m hydrogen 1, x squared hydrogen 1 plus y squared hydrogen 1 plus m hydrogen 2 equals x squared hydrogen 2 plus y squared hydrogen 2 plus m carbon equals x carbon squared plus y carbon squared plus m oxygen, which equals x oxygen squared plus y oxygen squared, which equals m 12m 16m. Okay, x squared is going to be 0 for all these. 0, 0, 0. Oh, and you know, since x is 0 for everything, I think I can simplify all the, or all the diagonal terms consisting of x. Yeah, that's probably the ticket. because those will just get, excuse me, those will get hit by a 0. And then, well, that'll be it. Okay. So y of hydrogen is going to be negative d rad 3 over 2. Negative d rad 3 over 2 squared. It's going to be positive d rad 3 over 2 quantity squared plus c carbon y is going to be right, these are 0 because carbon and oxygen are in the y-axis. Or no, they're in the z-axis. Well, they're in the z-axis, hence they are on the 0 of the y-axis. Yeah. Alright, so m d squared 3 over 4 plus m d squared 3 over 4, 0, 0. Okay. I z z is equal to, we have 2 of those, so 3 halves m d squared. Okay. Excuse me. Okay, so, right, so by observation, non-diagonal terms with x in it will equal 0, which implies I x y, I x z, I y x, I y z will equal 0. So that leaves our wait, sorry, which matrixes elements have we done? Done the diagonals, we've determined x, y, x, z, y, x, z, x are non-zero, so we have y, z, and z, y, which should just be the same thing. So y, z, is, here. Negative sum of each particle's mass times the included indices. That's going to be y alpha, z alpha. Alright, so that's going to be negative m hydrogen 1, y hydrogen 1, z hydrogen 1, plus, and then parentheses, negative m hydrogen 2, y hydrogen 2, z hydrogen 2, and we just keep going. M carbon, y carbon, z carbon, plus negative m oxygen, y oxygen, z oxygen. Alright, so it's going to be negative 1. Maybe I should go for that hot dog. I'm getting kind of pretty hungry actually. Negative m, y of hydrogen is off the plane, so it's going to be d rad 3 over 2. Actually, it's going to be negative d rad 3 over 2. D rad 3 over 2. For the first hydrogen, z is going to be, what is z? Negative d. Okay, negative d. Oh, and they cancel, so that should be 0 as well. Which I guess I could have done by observation, but whatever. Negative m. Hydrogen 2 is negative m. Has a positive d rad 3 over 2 component and a negative d component. This will be negative 12m mass. The y of the carbon is 0. So that's going to be times d, which is all rated in anyway. I think negative d over 2, yeah. Negative d over 2. Yeah. And plus negative 16m. Y naught is going to be 0. D over 2. There. those are zeros, and these will just end up with a negative md squared rad 3 over 2 and a positive md squared rad 3 over 2. So IYZ is just equal to 0 as well, which by observation implies that ICY is also equal to 0, and we have our elements. Okay. So basically everything on the diagonals was 0. Yeah. Or everything not on the diagonals was 0. What did I say? I don't know. Okay, so XX is 21 over 2 md squared. YY is 9 md squared. ZZ is 3 halves md squared. I guess I could factor out a 1/2 md, or md squared rather. That gives us a 21, 0, 0, 0, I guess 18, 0, 0, 0, 3. Oh wait, that should also be divisible by 3. Yeah. You could do 3 halves md squared. So you end up with a 7, a 6, and a 1. Is that right? Yeah. Okay. I don't know if that makes my life easier or not, but hopefully it does. Okay, so we have our, we should square that. Oh, I'm running out of time. Okay, we have our inertia tensor. If at t equals 0, the omega vector points in the z direction, what is the angular momentum? Now assume we have a steady rotation with this omega, that is omega is constant. Calculate the moment of inertia tensor as a function of time. Note that the moment of inertia tensor is a function of time because we are currently using the space frame tensor rather than the body frame tensor. Oh, okay, yeah, because this is rotating in space. If we localized it to the body, then there would be no rotation. Although I guess you'd experience like external forces, or extra forces, but okay. So if at t equals 0, the omega vector points in the z direction, what is angular momentum? Is that not just, let's see, we go from the moment of inertia tensor, so to go from I to angular momentum, what was that? Is that just, is that L? L equals I omega, is that right? Okay, so we're assuming that we have, let's draw this, okay. Okay, we have a constant, or I guess a scalar vector at that point, or a vector of scalars at that point, whatever you want to call it. Right, so calculate the moment of inertia tensor. Wait, no, so step 1. What is the angular momentum? That should be L. It's sanity check. L is the angular momentum, right? Angular momentum of an arbitrary angular velocity. Yeah. So angular velocity omega, some arbitrary thing. Angular momentum L. Okay, there we go. This is going to be the cross product. All that stuff. They do the derivation, blah, blah, blah. TLDR, you can do L equals I omega. Again, noting that I believe, given here. Omega is a constant, so L equals wait, omega vector points in the z direction, right? So, but it's a constant. So, sorry, what are the components of the omega vector? Let me think. So if omega is pointing in the z direction, then that must mean it only has a z component, right? I think. So then if you hit I omega, and that should be a dot product. It looks like a dot product. It looks like a dot product. Yeah. Of course, I is a 3x3, so hitting it with omega z should then mean that the angular velocity is just the, let's see, across and down, right? Across and down. So I guess realistically, it's what, I guess this is what's going on then. We have the I vector here. We're going to sub in what we just computed. 3/2 md squared times the 3x3 matrix, and then W should just have a 0, 0 omega z because it's only pointing in one direction. So this should just be yeah, 3/2 md squared. The only time that this matrix will produce a non-zero number will be for the last row and W sub z. Yeah. So then we get 3/2 md squared W sub z being the angular momentum. Now assuming we have a steady rotation, or I guess, wait, omega points in the z direction. Is that really non-zero? Or is that really 0 in everything except WZ? I'm going to assume it is because it makes my life easier. If we lose points, then we lose points. Okay. Now, assuming we have steady rotation with this omega. Okay, so we're going to make omega a constant. So we have 3 m omega d squared over 2 then. Now calculate the moment of inertia tensor as a function of time. Note that the moment of inertia tensor is a function of time because we're currently using the space frame rather than the body frame tensor. Why did we get the angular momentum then? We're supposed to go back to... Okay, so I guess if we do that, and we just consider it to be, again, a function or equal to I omega, then the I omegas cancel, we get... Wait, what? No, but we just got the omega. Why would we do that? It got mentioned in one of the recordings. Let me see if I can pull it up. Assume air resistance. Oh man, the one thing you never want to hear. Yeah. Assume air resistance. Assume everything is a fluid. Fuck. Anyway. We're looking for the office hour recordings. Here. See if it boots for once. Come on. There we go. It finally loaded. I think. There we go. Okay, so we're going to skip ahead. I don't remember when whoever asked it, but was it in the beginning? Okay, so we got verification. All the off diagonals for the inertia tensor do cancel. Okay, that's good. Oh, you know, one thing we also hate hearing is calculate the Coulomb force interaction. Oh man, I hated that. I don't even remember how to do them anymore. I guess the Coulomb interaction rather. Okay. All right. Yeah. Okay. So the x and y positions will change. Okay. I mean, that makes sense. All right. The high ground. Use the moment of inertia tensor to calc. Okay. So right. So maybe I just need to decouple this thinking. So we got angular momentum. That's fine. Maybe we just need to just stop the line there. And then after that, if the molecule rotates, then we know that the x and y. Well, we know what the x and y, how the x and y positions differ. So maybe we'll just box this answer, get that out of our mind. Yeah. So the hydrogen starts out all in the y-axis, right? So I guess if we're looking at it from the top, yeah, the hydrogen's here, and we'll just assume it's moving clock or counterclockwise. Yeah, so the new positions, so their starting positions are in the y-axis. Yeah. And let's assume omega is just the angle. So then the hydrogen 1 is going to be at the negative position. So it's negative cosine omega then. When omega is 0, this is 1. Negative makes it negative 1. That gives you the position. I guess that also needs to be hit by the distance away from the particle it is. So that's going to be the y value of the hydrogen. So d rad 3 over 2. Okay, so starts out at negative d rad 3 over 2 cosine omega. Hydrogen 2 is just the positive version of that. So these are the functions with respect to time, essentially. You know, going through omega is basically a time-dependent function thing. Okay, so we do that. So we get that. Cool. So then what? Okay, so with that new information, we want to compute the moment of inertia tensor as a function of time. Honestly, I'm running out of brain cells and, well, brain cells, energy. I mean, I guess I can go get a no, I can't go get a hot dog and then actually do work. It's not enough time. Yeah, I might just have to call it a day here. So omega is a function of t, so we can at least write that. So we kind of know where we're going here. So I guess we have the positions here. The inertia tensor equation that we had before was, I guess, bubble tea fixes all problems with studying. The problem, what bubble tea place is open at 11:30, dude? Oh, dude, I have a bubble tea ice cream left. I've been saving it since the place that sells it, you know, relocated. Fix my kitchen. Oh, oh man, I wish I had a kitchen though. Honestly, I put in an application. Actually, speaking of which, I haven't gotten any response about my housing application. So I don't know if I'm living in an apartment or in the residence halls, or if I'm just stuck living off the street next semester. I gotta figure that out soon. In fact, I want to know soon, especially for summer, just because I want to tell the person about that, about with the research thing that like, yeah, I'm gonna be here in the summer or not. So yeah, bubble tea. If you're still studying, yeah, maybe you can go for a bubble tea. I'm trying to figure out. I think I'm done. I'm not really quite sure what to do next here. And then D later. Well, let's listen to the here. Okay, so actually wait. So wait. Just sanity check. What are changing in time? X and Y. X and Y are changing in time. Yeah. Negative d rad 3 over 2 cosine omega t, positive d rad 3 over 2 cosine omega t. These are the y values. Yeah. Their x values are, I guess, let's see if this rotates first. If it rotates 90 degrees off from 0, we end up in the positive x-axis. I think I realized what I needed to do. Crap! I was just about to convince myself to just give up and go to sleep, but then I figured out what the hell I was supposed to do. Okay, d rad 3 over 2. So it's even positive x, and it'll be sine of omega t. And then this one will go into the negative x, so it should be a negative d rad 3 over 2 sine of omega t. Okay. All right, so this should give the x values and the y values. Yeah, right, let me think. So at omega equals 0, or time equals 0, resulting in some angle omega equals 0, you end up with cosine just evaluating to 1, so negative d rad 3 over 2, and positive d rad 3 over 2, with x is equal to 0. That's consistent with our starting position, right? So if we move forward some time t such that omega is equal to angle pi over 2, then the cosine ones go to 0. The h1 particle will move into the positive x-axis, at position d rad 3 over 2. The hydrogen 2 particle move backwards into the negative x-axis, position d rad 3 over 2. Yeah, okay, so this is x, y, and z. And then the z positions are the same as given initially. Okay, shit. I was just planning to go to sleep. But I don't have time to finish this anyway. Let me just write out the equations and then be like, okay, this is what I would actually do. Let's see. So the hydrogens are in the negative d positions. Okay. Okay. And then carbon and oxygen will just rotate. So in terms of their position, it won't change at all from up here, thankfully. Yeah, so I'm still gonna give up. I said 11:30. I'm gonna keep it at 11:30. And then do I equals I x x I x y I x z I y x I y y I z z. Or no, not I y y. No, I y y I y z. Okay. Don't slip up at the last minute here. I z y I z z. Okay. Right. Later. Yeah. Okay, I'm done. I'm done. I need rest. I also need to actually do. I've basically done no studying for tomorrow's assignment, so I really need to get sleep and do that. So we're gonna submit this. This week was way easier than last week's assignment, to be honest. I don't know what's going on with the difficulty curve. But whatever. All right, so I submit this and then one more and then Operation Yago for 9 days straight, basically. Or 9? No, more like, well, more like 5. Let's see. Tomorrow evening, 1, 2, 3, 4, 5, 6. 6 days, technically. Yeah, okay. Operation Yago is going to be a go. Yeah. All right, so assignments. Mark 7, submit, choose file, browse on my iPad, recent spreaders. Yeah, there we go. Submit. Operation Meet Yago. Sorry, I keep messing that up. Yeah. I think mainly so I'm thinking if I focus purely on finishing stuff over the week, I think I'm definitely not gonna, well, obviously I'm not gonna finish anything at this rate, but it's gonna be the same as what I've done before. I think I'm just gonna end up wasting the week or two in the sense that I'll achieve some stuff, but I'll mainly not achieve stuff, and then I'll just have to go back to my usual, school, studying grind. So really, I think the key thing with my spring break is I need to set up workflows. Like I need to set up a video editing workflow. I need to set up a, a, a shit posting workflow or something like that. I need to set up those workflows over the week. Really, is the main thing I need to do. Because I need to basically convert like the simple thing like, oh, I want to talk about a traveler's hook. Right now I can't make a video about that right away because it means I have to set stuff up and figure out blah blah blah. But I need to make it so I could think of that and then just arbitrarily make a video about it quickly. I need to set up a workflow that allows me to do that. I think that's really the key thing that I need to aim for this time around. Yeah. Just making sure my submission is all here. And I'm pretty sure I boxed the line. Yeah, okay, cool. So it's submitted. All right, so yeah, Konosuba, I don't know. Are you going to go to sleep right after this? Or are you still hanging in there with the... Actually, I don't know what you're doing. Are you doing the studying? Oh, shit. Yeah, well, I mean, I guess I can't really say I can... well, I guess all I can say is I can relate. I was going to say... maybe not. I don't think I studied as much. I honestly don't think I studied as much as you did back in high school. So, saying I can relate is probably a little bit rude to the degree to which you study, but oh, Skullmeat, welcome back. Okay, yeah, okay, it's good you caught me right here. I was about to go to sleep, so it's good to see you. It's good to hear from you. I was a little bit concerned that maybe you got a little bit too drunk last night, but it's good to hear that. It's good to hear from you. No, I don't think you're an alcoholic. I just I was just a little worried because I didn't hear from you. So, but it's good to hear from you again. But yeah, so I'm gonna end the stream today here. So yeah, Skullmeat and Konosuba, thanks for staying till the end. I guess Konosuba, good luck studying. Skullmeat, hopefully your server went well, or I don't know what to say, but hopefully it didn't crash again. But well, you can tell me all about it some other day. Sorry, I want to go to sleep, and sorry, I gotta, because tomorrow I still gotta study tomorrow. So, but after tomorrow, then it seems to be working. Okay, cool. So I guess that's all I really needed to hear. But yeah, so yeah, tomorrow's just I'm gonna study quantum mechanics all day. I'm gonna try to do as much of the homework, and then after tomorrow, then it's gonna be full on Operation Meet Yago time. I should stockpile some coffee tomorrow as well, so I'll go shopping as well. Yeah. But yeah, right. So hasn't rebooted. Okay, awesome. So it seems to be doing well at the moment. All right. Yeah. So yeah, Skullmeat, Konosuba. Take care. Stay safe. Have a good evening. We're almost at the weekend, although whether or not that's a good thing or bad thing probably depends on the person. But anyway, yeah. So yeah, thanks for coming by. Otsukare, oyasumi, owari.